The late Carl Sagan once commented that writing is this funny thing. It's a series of squiggles and black ink from which we can derive meaning as humans. These weird squiggles have had different forms across time and space. As we've evolved, so too has our writing, from the archaic, jagged, linear shapes in rocks such as Ogham in Ireland and Linear B in the Mediterranean, to the new curvatures of characters allowed from the surfaces of papyri, paper, parchment, and vellum. It's moved from the Merovingian scripts to Caroline minuscule to the quick hands of the students of Paris. The printing press brought stability and structure to forms, yet many variances in style and form has remained across the world. From Arabic to Chinese, from English to French, most languages rely on these weird, funny squiggles to convey meaning. In the past few years, the ability to interpret these handwritten funny squiggles has radically changed. No longer are we humans the only thing that can decipher their meaning. By converting these squiggles into numerical arrays, a computer too can learn that certain curvatures and changes in pixels carry meaning. They represent something more than a series of curves and jagged lines. They represent words, and when viewed collectively, these words represent lines, and those lines can make up a page, which is a small part of a large tome in a massive library. These large libraries, the holders of knowledge and the preservers of our past, are making novel advances and enormous leaps forward. In the past 2 years, a team at the Vatican has assembled, bringing together paleographers and data scientists. With the help of local high schools, they've managed to create a massive training set to automate the transcription of manuscripts. At the same time, new tools are coming to the hands of researchers. Tools like Transcribus allow those with no coding or machine learning knowledge to leverage the power of neural networks to automate the transcriptions of particular hands. Scholars such as Brandon Hawk, Antonia Krasil, and Nick White too have shown how these advances can be used to transcribe a fairly stable hand, Caroline minuscule, one of the scripts used as the basis for the typeface in the early modern printing presses. Caroline minuscule and other medieval scripts like it are relatively easy to train into models because of their consistent nature and their similarity to modern fonts. Transfer learning, when we use the training system from one system and use that to train another, allows us to make rapid advances in this area. All of this brings us to this moment here in 2021. In the next few years, there will be a large influx of textual data from these manuscripts. At this stage, most applications of machine learning have gone into the transcription of manuscripts. My research, however, is focused on what comes next. What do we do with this massive increase in textual data? Well, traditionally, we would collate it, and we'd create an artificial critical addition to represent variant readings and assemble a potential original version of a text. But these data can be used to achieve far more. These data are essential components for data augmentation. Most machine learning models are trained on clean data. This data is often normalized so that the machine learning models do not have to learn variant forms of words. In 2018, however, the way in which we train machine learning NLP models radically changed when Google released a paper detailing a new transformer-based method of learning, known today as BERT. Rather than removing noise from textual data, researchers left it in and allowed the model to learn the noise. For languages such as English, there is enough textual data to train robust BERT models because enough data is in raw text form. For dead languages, this is not necessarily the case. When working with a fixed corpus such as Latin, we have a finite amount of textual data. Textual data gathered from various editions in text forms such as the Patrologia Latina, Corpus Christianorum, and the Monumenta Germaniae Historica provide structured textual data with some variant spellings across publisher and time. These texts have, however, been very much standardized. Manuscripts are our last hope to capture variance as it originally existed. Because the Latin corpus is fixed, we cannot necessarily go out and find more training data. We can, however, make it. We can generate it. Variant readings in manuscripts allow us to make determinations about our data and write rules to augment it. Data augmentation is often done for the training of convolutional neural networks on images. An image may be rotated or cropped to provide a variant form of that same image, thus increasing the quantity of image training data without having to go out and gather more. For textual data, however, rules are more complex because language is more complex than a photo. To perform data augmentation on texts, one must understand how the language may have existed in all forms. This can range from synonym substitution to the changing of a letter from an A to an E. The variants that we find in manuscripts that will become available in the next few years will allow us to leverage what is considered a difficulty and a problem to many into an absolute strength. Join me on March 18th as I discuss how we can leverage the textual variants of manuscripts to perform textual data augmentation on medieval Latin and train robust machine learning natural language processing models that can handle the natural variants that existed in the manuscript tradition, to everything from parse the text, to interpret difficult to decipher words, and to perform robust tasks such as named entity recognition.